three basic experiments. And these experiments are mainly two experiments, and I will go for this, try to understand what is going to happen. And then we will discuss, okay, why we need quantum mechanics. In fact, we have very beautiful theory of Newtonian mechanics, that is classical mechanics. In spite of that, we need some new theory, some modern theory of the quantum mechanics. Okay. So let's try to go for the syllabus part. Then we will discuss how we will approach the thing. So today is just a zero class. This is just a warm-up class. Okay, this is just a warm-up class. We have to just warm up ourselves and we have to prepare in which direction we have to go. And obviously, the journey of quantum mechanics is a little bit longer one because syllabus is huge. But we try to make it very interesting. Okay, such that you will not feel bored. Okay, good. So in general, I started my class from the tools of quantum mechanics. But I feel in the last 13 to 15 years that we have to go more basic than tools. So I will start my quantum mechanics with the notation of quantum mechanics. So I will just go from notation. Notation and analogy. So first time I am going to introduce this notation and analogy. Then I will go for tools of quantum mechanics. So this is my first part. Then we will go for, this is, you can say, A. Then we will go for tools of quantum mechanics. Obviously, if I am talking about tools of quantum mechanics, then what is the theoretical tools of quantum mechanics? That is mathematics, basic mathematics. So I will discuss all the mathematics which is used into the quantum mechanics. So you not need to worry that whether you know this particular thing or not. I will separately do all the mathematics which will useful into quantum mechanics. So it's a very separate topic, tools of quantum mechanics. And then I will go for a historical development of quantum mechanics. And in this class, we will just go for the historical development in a very brief manner, but we will do this thing for the JAM students separately for each and everything, because in their codes, they are separately mentioned. But in the NET examination or JEST examination, this is not mentioned. But to know the basic thing, what is the conclusion, why we need this type of basically such that uncertainty principle, de Broglie wavelength, all this thing you have to understand in the historical development. And once you know these three things, then we will go for postulates of quantum mechanics. And these four things are very important to analyze the different system and different quantum mechanical approach to the system. And then we have to, once we will learn the postulates of quantum. What is postulates? These are the rules and regulation of quantum mechanics, the basic assumptions behind the mathematics of quantum mechanics. So we will just go for postulates of quantum mechanics. And after then, we will just go for application part. So then we will go for first thing is free particle. In the free particle, we have a lot of thing to do. Step potential. Then we have to go for a particle in box. Particle in box. Then we have to go for Dirac delta function. So these are the mainly three-part of and when you are going for the particle in box, you have infinite box, you have finite box, you have symmetric box, you have semi-infinite box, lot of different type of box we will discuss in the particle in box. And after then we will just go for this will be harmonic oscillator. And these are mainly one dimension, free particle in one dimension, harmonic oscillator in one dimension. So up to this, we are just talking about one dimensional system. That means there is only 1 degree of freedom. There is only translation motion are there. So we have to discuss all this thing here. I think, are you able to visualize to cover all the board? Anna? And then we will go for a next part, that is 2-dimension and 3D system. Okay, and these courses are up to this point. This is for NET exam, JAM exam, JEST, TIFR, all places you have to use this thing up to this point. Okay, and after then the JAM people can leave the class, or if they want, they can continue for the JEST and TIFR examination. If you are interested for the JEST and TIFR, then you have to go for next part also. Otherwise, you have to just leave here, and this is more than enough for the JAM examination. Okay. And then we have to go for basically quantum mechanics in spherical polar coordinate, spherical polar, where we will discuss the angular momentum, then we have to go for a spin, then we have to go for hydrogen atom. So, and then we have to go for approximation method. Approximation method. In the approximation method, we have to go for perturbation. Okay. Please mute yourself. है ना, किसी का song बज रहा है, mute कर लो. Okay, good, thank you. Perturbation, then we have to go for variational principle. And then WKB approximation. And after then, we have this is a very huge topic, है ना? बहुत ही ज़्यादा huge है. Then I can use this space also. Okay. And then we have to go for scattering. And J, K is there. And L is relativistic quantum mechanics. So these are the topics, and you have to follow all the thing. Depends on which type of exam you are going to appear. For the JAM people, you have to just cover up to this. This is necessary part for JAM people, but for NET, JEST and TIFR, you have to cover all these things. Okay, so this is your core of the syllabus, and each and every examination, the highest weightage will be quantum mechanics. Why it has highest weightage? Quantum mechanics had separate its own question, but once you learn quantum mechanics, then it will help you to understand atomic physics. It will help you to understand nuclear physics as well as solid state physics. So it's a very, and as well as your statistical mechanics. So there it will also help you. Okay. So this is the syllabus from different examination, and if you are going to cover this syllabus, you can just go for all the examination in the world, not only in India, in the world. Okay, and you can do much better. Okay, any query from your side? कहीं मैं मिस कर गया हूं तो आप मुझे सजेस्ट कर सकते हो. Any query?
सर रेफरेंस बुक्स बताइए.
यस, देखो मैं जो बुक फॉलो करता हूं, आई एम फॉलोइंग लॉट ऑफ बुक्स. सो एक या दो बुक नहीं. सो फर्स्ट मैं कोएन तनोजी and R Shankar I will follow for this part. Okay, so I am just saying you very frankly. So up to this part, I will follow Cohen and Tanorji. Okay, little bit of Jetli also. Okay, and this part I will just go for Griffith. Okay, this part I will go for R Shankar plus Griffith plus Jetli. Okay, this part I will go for all the books, all the possible books. जहां से भी problem मिले हम लोग उसे follow करेंगे. But
Sir,
thing is
that
that
part of the
कि आप
board is
इतने
not
book को
visible.
sorry
Sir, that part of the board is not visible. Where you have
this
written the
part
books about.
this
Yes,
part
sir.
this
Yes,
part
sir.
okay
Yes, sir.
okay now it's good.
Yes, sir. It's fine now.
Okay, it's good. Okay, देखो so you can have any book but for student देखो मुझे तो आपको पढ़ाना है तो मुझे अलग अलग जगह से चीजों को कलेक्ट करनी पड़ती है. But from student point of view, I will suggest you should go for Griffith, Quantum Mechanics by Griffith. Are you getting my point? So मैं आपको सजेस्ट करूंगा ग्रिफिथ को रखने के लिए पास. एंड बिकॉज ग्रिफिथ इज वेरी कॉन्साइज बुक एंड आपके एग्जाम में डायरेक्ट क्वेश्चंस उससे आ रहे हैं. सो यू हैव टू सॉल्व इट. एंड सबसे अच्छी बात है कि हम लोग ग्रिफिथ के, स्पेशली मैं ग्रिफिथ के सॉल्यूशन भी कर रहा हूं, जो इसका वीडियो सॉल्यूशन भी आपको अपने पोर्टल पर मिलता जाएगा, है ना. हमारा जो प्रवेगा का पोर्टल है उसके ऊपर आपको वीडियो सॉल्यूशन भी मिलता जाएगा, है ना. अभी मैंने एक चैप्टर का शुरू कर दिया है, सेकंड चैप्टर का भी कर रहा है. एंड आई विल ऑल्सो गिव यू होमवर्क फ्रॉम द ग्रिफिथ. Okay, just you have to solve this problem, you have to solve this problem. So if you want to ask me, sir, only one book I will suggest you, then I will suggest you Griffith. Okay, और अदरवाइज आपके पास सारी अपॉर्चुनिटी, आप जो भी बुक देखना चाहो देख लो. बट थिंग इज दैट अभी तक ऐसा कभी भी नहीं हुआ है कि जो कॉपी से, जो आपकी कॉपी बनेगी उससे बाहर कोई भी क्वेश्चंस आएगा. दिस इज नॉट गोइंग टू हैपन. यू हैव टू जस्ट कमांड ऑन योर कॉपी, ऑन योर बुकलेट. आपको जो 2 बुकलेट मिलेंगे क्वांटम के, काफी बल्कि बुकलेट है, 1 बुकलेट इज देयर. सो you have to just cover that booklet as well as your copy, है ना. So that is more than enough because we have to cover each and everything within a 1.5 month. So time is very important constraint. Okay, anything else? एनीथिंग एल्स? आप कुछ भी पूछ सकते हो, डोंट वरी. सो डोंट फील शाय, है ना. और उसे कोई टाइम भी नहीं किल होगा, बट ऑब्वियसली क्वेश्चन शुड बी सेंसिबल. चलो, so and I am again saying it that today is just a warm up classes, just a approach classes, because this is a very important topic, very interesting as well as tough topic also, है ना. Let's see how we should approach it. So I am not going to start even notation and analogy. I am just going to discuss a one particular experiment, and then I will ask you some question, and then we will realize why we need this beautiful subject named as quantum mechanics. Okay, chalo. एंड प्लीज आप क्लास में नोट्स उसी तरह से बनाओ जिस तरह से आप नेचुरल क्लासेस में बनाते हो, और don't rely on recorded videos. Recorded videos is just when you have trapped into some different work sometime, then you have to use that thing for the revision purpose. Okay, but in general you have to revise from your books. Okay, अभी भी TFR का एग्जाम हुआ है, lot of questions are coming from quantum mechanics from direct from copy, है ना. नेट का एग्जाम इससे पहले हुआ है. You can see the video of students who are selected. They are just a direct from copy. Okay, so just try to focus on copy and you will find you are able to solve each and every problem. But one of the very important thing is that you have to be very much honest that whether you are understanding this thing or not. Okay, so आपको बिल्कुल ही honest होना पड़ेगा इस चीजों को लेकर के. ठीक है? Okay, good. So let's try to go for two basic experiments which will the motivation behind this particular subject. Obviously motivation behind this particular subject is not only these two experiments, there are n number of experiments which will motivated people to create a new concept, create a new type of mathematics, create a new type of formulation to understand the nature. But these two are one of my favorite experiments which have done into the lab, and after then we will realize that okay, we need something very new to understand the law of nature and understand the basic to understand the basic experiments, the basic natural things to in our nature and everywhere. Okay, first is Young double slit experiment. I think everybody know Young double slit experiment, है ना? YDSE. सारे लोग पढ़े हो ना Young double slit experiment? I think we have done it into our +2. किया है ना?
Yes.
Everyone किया है. क्या किए थे Young double slit experiment में? क्या किया था? बताओ, anyone? Just tell me, क्या किया था?
सर एक सोर्स ऑफ लाइट, लेकिन सर
सोर्स ऑफ लाइट था और उसे हम क्या दो स्लिट से क्रॉस कराते थे, पास कराते थे, है ना? और एक स्क्रीन होता था. दिस इज अ सेमेटिक डायग्राम ऑफ यंग डबल स्लिट एक्सपेरिमेंट. यस
Yes.
ओके ओके. यहाँ पर एक सोर्स ऑफ लाइट था. दिस इज द कोहेरेंट सोर्स. कोहेरेंट सोर्स मींस देयर फ्रीक्वेंसी इज will remain same, either it is passing through slit S1 and slit S2. Let's say this is slit S1 and let's say this is slit S2. Okay, what we are going to do, we are just cover slit S2 and allow the light to pass from slit S1. क्या होगा ये बताओ? Whatever the light coming from S1, you will have some pattern something like this. ऐसा ही मिलेगा ना? अगर मैं S2 को कवर कर दूं तो okay. Now again I am going to cross slit, I am just going to cover slit S1 and I am allowing light to pass through S2. Then what will happen? क्या होगा? All light are passes through S2 and you will have some this type of intensity, isn't it?
Yes, sir.
ये आपको कब मिल रहा है? जब S1 ओपन है. ये आपको कब मिल रहा है? जब S2 ओपन है. But what will happen when both the slit is open? क्या मिलेगा? You will have अगर white light से कर रहे हैं, then you will have a dark and bright fringes, isn't it? ऐसा ही मिलेगा ना? याद है?
Yes, sir.
Something like this. And this theory is well expressed and well explained by Young, and he just give the concept of interference. ऐसा था ना? याद है? And what will be the intensity? Suppose this intensity is I1. If it is passing through slit S1, this intensity is I2 if it is passing through slit S2. But what will be this intensity? Is that this intensity is I1 plus I2?
Yes, sir. No, sir.
Huh? No. This is basically I is equal to I1 plus I2 plus what will be this one? 2 times root under I1 and root under I2 and cos delta, isn't it? And what is cos? What is delta?
phase difference.
Phase difference between these two light pulses. तो ये आपने ऑप्टिक्स में पहले पढ़ रखा होगा. And if you want, you can write it in term of amplitude also. A1 square, A2 square, 2 times A1, A2 and cos delta. What is A1 and A2? Is the amplitude. है ना? And amplitude square is nothing but the intensity. So we have just done this thing and we have done this experiment in our lab and we can easily see the wave property of light. किसका wave? कौन सी property को बताता है ये? Light का wave property. What is conclusion of Young double slit experiment? That is nothing but wave property of light. Okay. Now let us try to do this experiment with marble ball. किसके साथ हम कर रहे हैं ये experiment? हम करेंगे marble ball. Marble ball का मतलब समझते हो? है ना? Just a ball of glass, कंचा जिसे कहते हैं. Okay. So we are just going to do this experiment with marble ball. Now obviously we have to just keep this slit little bit wider such that marble ball can pass it. Here is a screen. This is your slit S1 and this is your slit S2. Now, and we are just throwing the marble ball continuously. Maybe you have some gun and you can just throw the marble ball from S1 as well as S2. Okay, this will be my S1 and this will be my S2. Okay, if I will close this S1, sorry, this S2, all the marble ball will go from which slit?
S1.
From S1. So this will be from S1. Okay. Now, if I will close S1, so this will be from S1. Now, if I will close this one, then what will happen to all the marble ball will come from where? From S2?
Yes, sir.
Yes. Yes. So this will be S2 from S2. Now, if I am going to open both the slit, then what will happen? Is that any interference pattern will be there? No.
No, sir.
There is not any interference pattern. Either your marble ball will go from S1 or it will go from S2. And this will be your I is equal to something like I1 plus I2. What is intensity in case of marble ball? Intensity क्या होगा marble ball के?
Number of marble balls.
Number of marble ball. Very good, very good. क्या नाम है आपका?
Dipanita.
Okay, very good. So number of marble ball. Suppose this is 500 marble ball. From S2 there is 500 marble ball. So 500 marble ball will go there and 500 marble ball will go there. So intensity is going to preserve. So I is equal to I1 plus I2. And this is why this is happening, because marble ball is well localized. You can chase how it is going there, and you can 100% say that it is going either from S1 or from S2. You know precisely it is going S1 and precisely it is going S2. Then you can easily say that this number of marble ball is here and this number of marble ball is here. So here it is wave property of light, and here this is particle nature of marble ball. What is particle nature? What is particle nature? That we can precisely say where is marble ball and how it is going. Means the position of the marble ball is well localized. So why we can have this kind of situation. Now, photon or this light and marble ball, in between we have n number of particles. And what will be that particle? That is basically, let's try to do this experiment with electrons. Yahan tak clear hai na, everyone? Let's try to go for this experiment with electrons, and let's try to see what is going to happen with this particular electron and how we can understand it. This is well understood with the help of wave nature of light. This is well understood with the help of Newtonian mechanics. But if we are going to do this experiment with electrons, let's try to see what is going to happen. यहाँ तक कि हर एक लोगों का? Okay. Let's try to do fit the electrons. So, sorry. This is your two slits. This is my screen. This is my S1. This is my S2. Okay. Now, I am just going to cover this S2. What will happen? Electron will pass from S1. So, we have this kind of situation. Everyone is comfortable? And so this is from, if I am just closing S2 and this is passing from S1. And this is your screen. This is just a schematic diagram. Now, if I am going to cover this S1, then electron will pass through S2. We will have this kind of situation. Now my question is that, what will happen when I will just going to open both the slit? What is your expectation?
As like marble ball.
It should be behave like a marble ball. We can just assume that electron is just a tiny particle, isn't it? And so why it should behave like a marble ball. But surprisingly, what is going to happen? It will give you just a interference pattern. People thought one electron is going to interfere with another electron. Maybe this kind of situation can be possible. So what they does, they send the electron one by one. Are you getting my point? They send the electron one by one. And then again, what will be their expectation? Like marble ball or electrons? Sorry, like marble ball or light? Like a marble ball. Like a marble ball. But surprisingly, even you are sending the electron one by one, and you are just doing this experiment over a time, over a long period of time, again you will find there is interference pattern just like a light. My goodness, what is to happen? Electron is just behaving like a light wave. It is just giving you interference pattern. And how you are getting this interference pattern? You can assume something like this. First electron can come here, second electron can come here, third electron can come here, fourth is here, fifth is here, sixth is here, seventh here, eighth here, ninth here, 10th here. And so why you have this kind of situation, and you will find something this kind of intensity pattern. This is miraculous, unexpected, isn't it? But
Yes, sir.
there is a lot of twist here. There is a lot of twist here. Now look at what is going to happen. We are just again, we are going to revise this experiment with some new methodology. What we are going to do, again we are going to, now we are putting some sensors here. Sensor, or I can put some eyes here, okay? Some sensor here and some sensor also here. And I am putting eye here at the slit S1 and at the slit S2. And then if I am going to close S2, I have exactly this kind of thing. If I am going to close S1, I have exactly this kind of thing. I am just putting it here. But now you can see, so ऐसे कर देते जैसे पहले कर रहे थे. So this is for S2 when you are putting the eyes here. But now just tell me what will happen when you have S1 and S2 both are there and you are putting the sensors at each and every points. Then what is your expectation? Like a wave, isn't it?
Yes.
Huh?
Interference pattern.
Interference pattern.
Yes.
But now you have exactly marble ball type pattern. What is going to happen? Again, you will pull all this thing and you will see the on and average what is going to happen. You are not able to chase the electrons, and what you will get? You will get again interference pattern. So this is with I and this is without I. If I am saying with I, that means I am chasing the electron point by point. I can, if I am able to chase this thing, then it is just behaving like a particle. And if I am not able to chase, then it is just behaving like a wave. My goodness, what is going to happen to this particular electron?
Dual nature.
Dual nature. And how can I explain it with the classical theory? Neither classical wave theory can explain the combined both the thing, neither classical Newtonian theory is going to explain it. So it's a big task for human civilization that how we can explain this weird behavior of electrons. Are you getting my point?
Yes, sir.
I am just telling you a story in a very simple and lucid manner. Obviously, the experimental setup will be little bit more complicated and more different. But what I am saying what is the experimental results. And once you can see this type of experimental result, how you can explain it? This is one of the toughest thing and toughest challenge ever for the human civilization. We have not any solution right now. Are you people are you people understand this thing? Obviously not. Obviously not. This is beauty of quantum mechanics. It is very difficult to understand, and even it is very difficult to understand, we can easily use it by the help of beautiful mathematics and experimental setup. Only 2% knows what is going to happen, either electron or God. Okay, so this is one of my favorite experiment, which create a miracle in the world of science. Let's go for the another one, and that was more weird. That was more weird. Okay, let's try to go for this, and we will understand each and everything once we will go for the postulates and all this thing. Okay, so don't worry about this. Yes, boliye.
Sir, when we are using the sensors, so it
Hmm.
means we are tracing the electron.
The
one
tracing
by
the
one.
particle. If I am talking about we are using the sensors, that means we are tracing the particle. Yes.
Okay. So it means when we are tracing, it is behaving like a particle.
Behaving like a particle.
And when
And
we are
electron is an electron. And listen, electron is electron. It's just a particle. Or it's just a wave, isn't it?
yes,
When
sir.
you are seeing this particular thing, this particular result, it is just a particle. And if you are seeing this particular result, it is just a wave, isn't it?
Yes, sir. So, sir, my question is when we are tracing, it is behaving like particle. And when we
Yes.
are not tracing, it means we are observing from ground frame. Observation is
That
from
is nothing
which
to do with the
point?
frame. We are just in the inertial frame. Don't worry about this thing. Okay.
Okay, sir.
So in the same lab setup, you are doing both the experiment. Okay.
Yes, sir.
Sir, without
So
I
don't make it complicated with the reference frame. Nothing to do with the reference frame. Okay. Yes.
Okay, sir.
So without I means we are obtaining a complete means all the electrons are incident and we are obtaining pattern. No?
Yes. 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 Exactly. Now, question is that you have to accept this result, but we are not able to explain this result. Are you getting my point? When we are able to explain this result, when we understand quantum mechanics. Are you people okay?
Yes, sir.
Hai na? Yes. So don't ask me, sir, why it is happening and how it is happening. We can give the answer once we will cover the whole syllabus of quantum mechanics, then we can give the answer. I am just giving you the challenges before going to deep study of this particular topic. Look at the challenge. The challenge is very weird, very random, isn't it?
Sir,
Huh?
सर हिस्टोरिकल पॉइंट ऑफ व्यू से यंग डबल स्लिट एक्सपेरिमेंट ही क्वांटम मैकेनिक्स का ओरिजिन है.
This is one of the experiments. This is one of the experiment, है ना? Obviously.
Yes, sir.
This is the one of the experiment. आप किसी एक एक्सपेरिमेंट को नहीं बोल सकते हो कि ओनली देखो क्वांटम मैकेनिक्स एक ऐसा टॉपिक है जो कि किसी एक पर्सन के थ्रू बनाया हुआ टॉपिक नहीं है. ओके.
Yes, sir.
So this is basically outcome of different minds. Different minds. I will tell you a story. I will tell you a story when we will go for the historical development. Then you can think, then you can see that the story will be not only from the science point of view, rather it is from the economics point of view, rather it is from the political science point of view and the politics point of view also. So quantum mechanics is not only a subject to the science. It's a subject to the philosophy. It is a subject to the perception, understanding of perception, understanding of philosophy, understanding of using the beautiful mathematics to understand the law of nature. So you cannot separate quantum mechanics in the science or arts part. This is just a combination of each and everything. One of the very beautiful writer, David Bohm, he was mainly a philosopher who write one of the very beautiful book of the quantum mechanics. If you have some time, you can read that particular book. The first part of that book is awesome. How you have formulated quantum mechanics. Are you getting my point? So give me some time. Give me some time. We can explain each and everything. But I am very happy that you are raising the question. That means you are putting your interest into this particular subject. But raising the question doesn't means you have answer. Are you getting my
sir.
point?
That's why.
And this is how quantum mechanics developed. There are a lot of things happening to the world, lot of things happening to the nature, but we are not able to explain it before understanding this particular beautiful subject of quantum mechanics. Are you getting my point?
Yes, sir.
Let's try to go for the next experiment. This is more dangerous experiment. Okay, let's try to go for this. Okay. Okay, so let's try to go for I think everybody know little bit of polarization because everybody have done their +2 and we know polarization. What is polarization? So we have a polarized light, unpolarized light, isn't it? That means electric field is randomly oriented, isn't it? Suppose I will put the polarizer in a z direction. Suppose this is my z direction. I will put the polarizer. What will happen?
It will polarize in Z direction.
Only those component of lights will pass through polarizer which is parallel to z direction, isn't it? Yes,
Yes.
or no?
Yes, sir.
Yes. Okay. So what will happen? Only these electric fields will be there. Now, again I will, suppose it has intensity I or I naught, take it I naught. And again I am going to polarize it into z direction. Then what will happen? All this will again cross it. Cross kar jayega na?
Yes, sir.
Yes, sir.
Because this is polarized into the z direction, so it will again cross it. Okay. Now I am just putting this polarizer in a x direction. What will happen?
Cross नहीं कर पाया.
What will happen? कोई भी cross नहीं कर पाएगा. Okay. So you will get nothing. And this experiment is well defined with the concept of polarizer and Malus law. आपने इसे देखा होगा polarizer किस तरह से काम है, and this is very common sense thing that hence polarizer in z direction, it is just coming, the z component will be passed through here. When it is x direction, x is perpendicular to z, so you will get nothing. Good, very nice. Let's try to do something like this experiment with electrons. And let's try to see what is going to happen. So that experiment is basically a Stern-Gerlach experiment. A Stern-Gerlach experiment. What is this Stern-Gerlach experiment? You have magnetic field. Okay, you have magnetic field. And electron is passing through this magnetic field. Electrons are passing through this magnetic field. And electrons have two direction of magnetic moment, either +1, you can assume electrons, and you are passing the some atom. Let us assume silver atom is going to pass through this particular magnetic field. And electron, and we know that electron can move either in clockwise direction or in anti-clockwise direction. It can just spin either in clockwise direction or in anti-clockwise direction. So magnetic moment will be either up or down. Okay? कितने डायरेक्शन हो सकते हैं आपके इलेक्ट्रॉन के मैग्नेटिक मोमेंट के? Only two direction. If clockwise, it is up. If anti-clockwise, it is down. So what we have seen on the screen, we have either plus or we have either minus, and this is in the z direction. So this is something like your electron can be polarized either in plus direction or in minus direction. The whole setup can be symmetrically given by this notation, Sg in z cap direction. Electron is coming. It will, when it is, some electrons are here, it is passing through this particular setup, then this is your setup. Then you have either plus or minus. Okay, everybody understand this particular setup, especially my jam friends. आपको कोई दिक्कत तो नहीं हो रही है ना? समझ में आ रहा है ये? आपको जस्ट ये समझना है कि इलेक्ट्रॉन यहां से क्रॉस कर रहा है, अंदर कुछ कुछ हो रहा है, and then you will get either plus or minus. Are you getting my point? Now, so what I can say electron is passing through this particular box, and this box have some magnetic field, some screen. So why? We are just getting this thing. So input is this, output is this. So this is my input. This is something like box. This is my output. Okay? Something like this. Now, let us try to see what is going to happen.
Z cap denotes the direction of magnetic field.
Yes, Z cap is denoting the direction of magnetic field. So your electron is polarized into Z cap direction. Its magnetic field, its magnetic moment is polarized into Z cap direction, either in plus direction or in minus direction. Okay?
Okay, sir.
Okay. Good. अब जरा देखते हैं क्या हो रहा है. पहले मैं फिर से इसे रिपीट कर रहा हूं. What is input? What is input? Unpolarized.
Polarized light.
Okay, this is unpolarized. What is this thing? This thing is one box.
Z cap.
In which direction it is polarized?
Z cap.
Z cap direction. What is output?
Polarized light.
Polarized in
What is output? Z cap direction.
In Z cap direction.
Polarized in Z cap direction. Again, it is polarized in
Z cap direction.
Z cap direction. What is output?
Light polarized in Z cap direction.
Z cap direction. It is polarized in
X cap direction.
X cap direction. What you will get?
Zero output.
Zero output. Very good. Now, let us try to go for this. एकदम exactly same बना दे रहे हैं, है ना? So this is my incoming unpolarized, and this is SG experiment into Z cap direction. What will be output? Plus and minus. यहां तक आ गए हम. Either you have get plus or you will get minus. I am just going to cover this minus sign. I am just going to cover it, and I am going to allow this thing with SG in Z cap direction. What you will get?
Plus.
Plus only, sir.
Plus.
in Z cap direction.
We will get what? Plus sign, isn't it? Very good. So we will get plus sign. Okay. Again, I am going to polarize in SG in X cap direction. What you will get?
No.
Same.
Very good. What you will get?
Nothing.
Nothing. We will
Your common sense will tell nothing, isn't it?
Yes, sir.
यही तो है ना? But what you will get? You will get plus and minus. Again, you will give two beam, two spot. Are you, huh? Please mute yourself. Mute करके रखिए. Mute करके रखिए. Are you getting what is difference between classical polarizer and this particular behavior of the electrons? Now, look at here. I am just going to cover it. and again SG into z cap direction. What will be your common sense will tell?
Nothing.
Nothing, but you will get again plus and minus. My goodness. You cannot predict your final outcome by knowing the previous outcome, isn't it? यहां पर आप previous outcome के basis पर final outcome को predict कर पा रहे थे ना?
Yes, sir.
Yes.
Yes.
You know the status of each and every step. But here you cannot predict what is going to happen. So this type of behavior of electrons cannot be explained by classical physics. So two things we have seen, two broad things mainly. The first thing we have seen is the dual nature of electron. And second thing we have just seen that unpredictable nature of final outcome. So broadly, this is the biggest challenge. This is the big challenge, that how we can understand these type of experiments. And this is not only this experiment. The next one is hydrogen atom spectrum is one of the very important thing, that why we have this type of spectrum for a hydrogen atom. So all these things will create a mesh, and obviously the solution is only and only quantum mechanics. So how we can explain all this thing? Obviously we cannot explaining without doing some beautiful mathematics. Are you people
Sir.
happy? बोलो.
या प्लस और माइनस मतलब एक रिप्रेजेंटेशन के लिए यूज
एक
हुआ है.
रिप्रेजेंटेशन है कि इलेक्ट्रॉन क्लॉकवाइज घूम रहा है या एंटी क्लॉकवाइज घूम रहा है. ठीक है, आप उसको अप भी दे सकते हो, डाउन भी दे सकते हो, है ना, किसी भी तरह का आप
Yes.
नोटेशन दे सकते हो. मैंने प्लस और माइनस का नोटेशन दिया है. ठीक है,
Yes, sir, clear.
सो व्हाट इज योर चैलेंज? आपका चैलेंज क्या है? These two things is the most important challenge, and lot of people work on this particular topic, mainly this, to understand this type of experiment. There is another experiment known as Davison-Germer. There is experiment known as photoelectric effect, Compton effect, and all experiments are not able to understood by the mainly classical mechanics. So obviously we need to learn a very new theory, a new concept, a new philosophy, that is basically what? Quantum mechanics. Okay, यहाँ तक clear है everyone? Are people enjoying this thing or not? Because interest is very important. First you will
Yes,
get
sir.
interest, then only you can learn. है ना? Yes.
Yes, sir.
Now, so how we will approach this quantum mechanical thing from the tomorrow's class? This is just a warm-up class. Don't think this is your first class. This class is only to develop the interest, to make your mind little bit broader, and after then we can go for this. Now, आप मुझे ये बताओ, if you people want to learn French, आप कोई फ्रेंच स्टोरी पढ़ना चाहते हो, तो how you will read फ्रेंच स्टोरी जो फ्रेंच में लिखा है, उसके लिए आपको क्या क्या करना पड़ेगा?
तो सबसे पहले इसके नोटेशन और बेसिक को जानना होगा.
सबसे पहले फ्रेंच के स्क्रिप्ट सीखने पड़ेंगे, है ना?
लैंग्वेज सब्जेक्ट.
सीखने पड़ेंगे कि नहीं? Yes, you have to first understand script. अभी उन्होंने कहा कि we have to know the notation. So quantum mechanics have also their script and also their notation. So first आपको notation सीखना पड़ेगा. Yes. Then आपको क्या सीखना पड़ता है? किसी भी बुक को सिर्फ notation पढ़ करके आप पढ़ सकते हो क्या?
नहीं सर।
नहीं, जैसे कि जब तक आपको नोटेशन से चीजें कैसे बनती है वो नहीं पता होगा, नहीं पढ़ सकते हो, है ना? So then what you have to do?
Understand grammar of
Understand the grammar of that particular thing. But between the grammar and script, you have to try to connect this script to a different words, है ना?
yes sir.
है ना? पहले आप क्या पढ़ते हो? First will go for ka, then you will go for what? Kamal? Yes or not? You will read
Yes, sir.
ka separately, ma separately, la separately. Then you will connect it and you will know this is Kamal. Something like this, isn't it?
Yes sir.
Okay. If you learned quantum mechanics, you have to learn Q first. U, A, N, T, U, M. Then you can connect it. Then you can know what is your quantum mechanics. Okay. Now, script notation. Then you have to learn little bit of word. है ना? कुछ words आपको समझ में आने चाहिए. And then you have to learn what? Grammar. Isn't it? And once you learn all these three, then only you can learn the storybook. Everyone is समझ में आ रहा है आपको? आपको करना क्या है? तो सबसे पहले हमें क्या सीखना पड़ेगा? And quantum mechanics is entirely new book.
Notation.
सबसे पहले हमें स्क्रिप्ट और नोटेशन पर कमांड करना होगा. So this is basically my first class notation and script, and then we will go for understanding these words. So this will be my tools, and this will be my notation, and here will be postulates, and then you can read the books, and different books have different story. So story is particle in box, harmonic oscillator, and all these kind of hydrogen atom. These are different stories we have to learn. Are you getting my point?
Yes, sir.
Anna? So be very much clear what we have to do. So next class only, we will just try to learn different type of script. And then we will go for tools. In a tools, we have mainly matrices, a little bit of probability. Okay, these are the tools. But before that, we have to learn what are the different notation. Okay. So I will stop my class at this point of time, and tomorrow we will meet with the first class of the quantum mechanics, that is notation of quantum mechanics. ठीक है?
Yes, sir.
Yes, sir. Thank you, sir.
So in the tools of quantum mechanics, we have vector spaces, the matrix, and probability. Okay, three things is very important tools, and postulates, and after then you can easily understand the postulates. ठीक है?
Okay, sir.
And once you will learn the postulates, understand the postulates, you can do each and every problem very easily. ठीक है? चलो.
Sir,
If you want to ask
Okay, sir.
anything, you can just
Sir.
ask me. बताओ.
Sir. So basically, what is the weightage and marks of this quantum mechanics in the exams or net?
In the net examination or in any examination, the highest weightage is from quantum mechanics. Okay. So out of 200, if you will cover the quantum mechanics, you will easily get 25 to 30 marks. Okay.
Okay, sir.
In every examination, the highest weightage is either quantum mechanics or mathematical physics. Okay.
Okay, sir. Sir, and one more
Okay.
question related exam.
Mhm.
So which is
So in the
approximate-
net examination,
Yes, sir.
examination,
Yes,
so in the net examination, it will approximately eight questions will be there, 8 to 9 questions will be there.
Okay.
Okay, 8 to 9 question, and it's a huge percentage. And thing is that once you understand quantum mechanics, then you can easily do better in atomic physics, easily do better in nuclear physics also. Okay, so it will
Okay.
support different topic also. The most important topic is obviously mathematical physics, because
Yes,
once you do the mathematical physics, it will support each and every topic. But once you do the quantum mechanics, obviously it will support all other topic also. So it is very important that once you command on this particular topic, there are fair chance to for selection, है ना?
Okay,
जैसे
sir.
इस बार आप देखोगे पिनाकी स्टूडेंट हैं, आपका कभी चाहो तो उनसे बात कर सकते. Is that Pinaki is there? No, I think he is not there. He is already selected. He is in his masters, and he solved all the problem of quantum mechanics in examination. And even he is not completing his course also, and even he is not completing his masters also. Only doing this course, he is able to solve all the problem of quantum mechanics.
Sir, and when will be the next upcoming exam? Any idea?
I cannot say about this, but I think it is too late, so it will be maybe in February and something else, isn't it?
Okay, sir.
Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.